You're listening to the Common Descent Podcast. Hi, Will.
Hello, David.
Hello, listeners.
Hi, everybody.
And welcome to the Common Descent Podcast, episode 21.
Woo!
How about that?
Our podcast is old enough to drink.
Our podcast can get a drink.
Yeah.
This would have been a great episode for Michelle to join us. On today's episode of the Common Descent Podcast, we are talking about a topic that it's a little surprising that it took us 21 episodes to talk about.
Mm-hmm.
And that is dinosaurs.
Yeah.
As a whole, just dinosaurs, the animals.
Yeah.
And I say that as though we haven't mentioned dinosaurs on literally every episode of the podcast.
Yes.
So they're finally getting their own episode, and this is it.
We're giving them a formal, introduction and addition instead of just peripheral mentions.
Yes. This is not specifically a requested episode, but there are lots of requests for dinosaur-related episodes.
Mm-hmm.
So this is sort of a prelude, sort of laying the foundation for us to do a lot of requests in the future that'll be dinosaur-related.
Yep.
So that'll be good.
Yeah, I'm excited for those because we've gotten some really cool requests for interesting groups in dinosaurs.
We have. In fact, speaking of requests, I was looking over our list because we got a few new requests over this weekend. We now officially have enough listener requests to fill a full year.
Yeah.
Of the podcast. If we did every listener request on our list as an individual episode, we could do an entire year of them.
Which is
pretty awesome.
That's awesome,
yeah.
You guys. Keep it up.
Now, we won't do that because some of those requests might get merged and some of them might have to wait until later, and there's still stuff that we want to do episodes about. So we probably won't do a full year of listener requests, but we could, and how cool is that? So keep them coming.
Yes.
Speaking of listeners, this is the first episode of the month of November. In fact, this comes out on the 5th of November.
Mm-hmm.
I almost forgot that, and then I remembered.
Yeah, you really should never forget it.
It's a good day to remember. What a good movie.
I don't know why anyone would ever forget it.
This is a great time to remind everybody that November's episodes of the Common Descent Podcast are brought to you pretty much entirely by donations from our patrons.
Mm-hmm.
People who subscribe and donate to us on Patreon get access to all sorts of cool stuff, like unique status updates and behind-the-scenes cool stuff, like our after-chat recordings. The podcast will always be free. We're never going to hide the educational stuff behind a paywall or anything like that. But getting donations from these listeners really helps us to keep the podcast going. And in fact, like I said, it's paying for the podcast at the moment.
And hopefully we'll be able to upgrade our setups and do even more as time goes on.
Yeah, both of our headsets are being all creaky and noisy. And boy, it'd be great to get something better than that.
Yep.
So if you feel like donating to us in a financial sense, please join us on Patreon. Even if you don't, we love you anyway. Keep listening, keep making requests, review us on iTunes, all sorts of cool stuff like that.
Absolutely.
But, that all being said, we have some dinosaurs to talk about. Before we can talk about dinosaurs, we got to talk about the news.
Yeah.
Take it away, Will.
All right, so to start the news, and before we talk about dinosaurs, I have a dinosaur to talk about.
Oh, good. That's what I was hoping.
We can't actually wait. So I am talking about a very recent news article. Came out just a few days ago, and it's about a not newly discovered, but a newly analyzed little theropod dinosaur, where they've looked at the coloration of the feathers that were preserved on 3 specimens, the best 3 specimens, to find the color patterning, which we've talked about this before with dinosaurs in previous news articles and everything.
Mm-hmm.
This one just has really interesting patterns, which is very cool. We're starting to get, on the more we do this, we're starting to find some very interesting results.
Yeah.
So this study is Fian Smithwick et al. And published in Current Biology. And the dinosaur they were analyzing is from the early Cretaceous, about 125 million years ago, China. So where a lot of our feathered little dinosaurs are coming from, yeah. And it's Sinosauropteryx prima, or prima.
Yes. Sinosauropteryx was actually the first dinosaur that was discovered with definite feathers.
Mm-hmm. So it's already a famous individual there.
Yeah.
Now we've taken a closer look. And as has been done with other feathered or fuzzed dinosaurs, they were able to look at the remnants of the pigment molecules in the feather impressions.
Yeah.
And a lot of times it doesn't, many of those, there's a small range that survive or that we've been able to detect. So often you're able to get light dark results.
Yeah, a little bit of color.
Exactly. You're not going to get a nice rainbow spectrumed result, but you're going to be able to tell roughly how this thing was shaded and the intensities of those shadings, which is informative for a lot of reasons. This one resulted with a really cool look. It has, as they call it, a bandit mask.
Yeah, like a raccoon.
Dark patches around the eyes, which is common in animals today. Raccoons, of course, are the famous ones, but I mean, other animals have shading around the eyes, like the famous black marks under a cheetah's eye and things like that.
Yeah.
So it has similar patterns around its eyes that we see in animals today, and it has banding along the tail, so basically rings going down the tail, and is countershaded, so darker on top, lighter on bottom.
Yeah, there was another dinosaur not too long ago that was found to be countershaded. Same researchers, actually.
Yeah, and same general area. So they actually comment on that because that tells us something interesting about the environment. Because one of the things they looked at with this little theropod was what was its countershading best used for, and they did it in a really cool way. I really like it. So they scanned, the fossil, made a 3D image with the shading put in from all their information. So basically they 3D designed dinosaur and then lighted it in that 3D environment with different intensities and shadings.
Yeah.
Different amounts of lighting, and then photographed it in the 3D program to determine which amount of light was best suited for the counter shading it had.
Yeah.
And what they resulted with was this one was made more for open environment, running around plains, fields, what have you.
Cool. That is to say that that light dark pattern of its body best matched the light dark pattern of natural shadows that you see in an open plain style environment compared to like a forest where it's a bit more shady.
Yes, and that is the other example, which is what our other dinosaur that we mentioned, which is I can never remember how to pronounce the beginning of it. Cycatosaurus.
I've been bouncing back and forth. I go
right?
Psittacosaurus.
Psittacosaurus.
Yeah.
We'll go with that. I like that one. Psittacosaurus also had counter shading. It was a little ceratopsian. And it's, though, when they looked at it with this same method, was adapted for forest.
Yeah.
So it was hiding in the already dark, leaf-covered areas of the forest, while our theropod was designed for open environment. And since they were both found around the same prehistoric lakes, this tells us that that was a fairly diverse area with multiple environments fairly close together.
Very cool.
Yeah.
It's super cool what kinds of things you can infer from color patterns.
Absolutely. And that's one of the things they mentioned, is that not only can this start telling us potentially about the behavior of the animal, but it also can tell us about the environments. It starts telling us what kind of things were they trying to hide around, which is cool.
Yeah, it also suggests that whoever was hunting them, whoever they were hiding from, was very visual
Yes.
based in their hunting, which makes sense for other dinosaurs.
And so that's one thing, that finding this much color in dinosaurs in general has just led more and more support the fact that these were very visual animals, that, and not only for hiding from their predators, but also for hiding from their prey. They were utilizing camouflage in multiple ways. So you get some really cool results looking at the color of dinosaurs.
Yeah, coloration and pigmentation inference, right? Interpretation in extinct animals has been popping up more and more, and it's becoming very common, particularly with these researchers.
Yeah.
And man, I really hope that it ends up all being good. Whenever there's something new and exciting like this, there's always that little concern where it's like, all right, have we tested this enough? Are we running away with it? Like, are we... I'm holding out hope that this withstands all the tests.
And that's why typically whenever there's new idea, and it's easy for these semi, not necessarily naysayers, but people who are hesitant to just talk about it as a definite, can often feel curmudgeon-y, but it's for that reason of, this is a really cool thing, very new, and as we said in the last episode, at any moment you could discover that one thing that goes, oh, none of the things we thought were pigments.
Yeah, and that's been suggested, right, and I bring that up because there is discussion that there are people who aren't convinced, so.
It's still a young field. It's still a young type of research.
Yes, we shall see.
Yeah. All right.
Well, since you talked about your dinosaur news here on our dinosaur episode, I am going to transition us over to a news story of mine where I'm going to talk a little bit about dinosaurs.
Oh, okay.
Yeah. So this is a new study in Nature, Ecology, and Evolution by Christopher Doughty. It is a very simple and straightforward investigation with some really cool discussion, I think, to go along with it. Basically, what this study was looking at is this question of the importance of big herbivores for spreading nutrients.
Yeah.
Right? So, obviously, big herbivores have a big impact on the land. They eat lots of plants, they walk around, they poop out what's left, and this process spreads nutrients around. And so there's plenty of theoretical support for this notion that ecosystems with big herbivores are more nutrient rich.
Yeah.
But this hasn't really been experimentally looked at.
Yeah.
So what this study did was looked at it. So this person took some coal, right? Coal's remains of plants, from two different time periods to compare. The first was the Pennsylvanian, which is a little over 300 million years ago, a time where there were no terrestrial vertebrate herbivores. Right? All early amphibians, early tetrapods, things like that.
Yeah.
And then the Cretaceous period, which was loaded with all sorts of herbivorous dinosaurs. Some of the largest herbivores in history.
Exactly.
Yeah. Now, if you're going to look at the effects of herbivores on landscapes, that's a place to do it.
Go big or go home.
Yes, exactly. Looking at the two different sources of coal, he compared the concentrations of the kinds of nutrients that are spread by animal herbivores, compared with the kind of nutrients that are not, right? The kind of nutrients that spread around by weathering and stuff like that.
All right, yeah.
And what he found was, not only did the Cretaceous have a majorly higher concentration of animal-spread nutrients, more than 100% higher, but there was also a significant difference in the dispersal of those nutrients, that they were more spread out across the environment. The nutrients were more mixed, they were mixed up, they were showing up in different places, they were being transported around the ecosystems more consistently. But aluminum, he specifically looked at aluminum, did not show that pattern. Aluminum is a nutrient that is not spread during animal dispersal, but is spread during the same sort of weathering processes that these other nutrients are. So the fact that we were seeing this big difference in the animal-related nutrients and not in the others is an indication that there was a significant change in how nutrients were being spread across the environment, because you had an ecosystem with much more herbivores, with much more animal transporters for those nutrients.
that without them moving things around, the important nutrients would have been moving around just as much as the aluminum and would have been limited.
Yes, exactly. That's the whole study. That's it.
Yeah.
It is straightforward, it's simple, it's elegant, I think,
Mm-hmm.
and it's got some really cool implications for the importance of big herbivores in ecosystems, especially in a world where we happen to be losing a lot of our big herbivores.
Yes.
So it's got it's a fun topic to think about.
Absolutely.
And I hope that there's more follow up to this because this seems very simple and preliminary, and I like that. And hopefully there will be people who follow it up with other related studies.
Well, it'd be cool to see these studies done, in multiple environments. An African plains study, a Indian forest with the elephants there, the areas known to have bison versus the areas that don't. It'd be fun to really see the comparative, trends between the different ecosystems and territories that have these big herbivores.
Yeah, absolutely.
Yeah, big herbivores are cool. And the first thing that I thought of when you started talking about this article is the way I've always pictured large herbivores in an environment is like a bulldozer.
Yeah.
Like when if you're looking at nutrients and stuff as moving dirt, you could move stuff with a shovel, but it's going to take a lot longer, and you're probably not going to move it as far because you're going to get tired.
Yeah.
So yes, things get moved around when small animals are eating it, but if a bulldozer comes over, it can move a ton as far as it wants because it's big enough. And sometimes they're almost a direct comparison to bulldozers, because I was reminded of the guy in Russia that's trying to recreate the mammoth steppe.
Yeah.
And he uses a tank in place of the mammoths he's missing.
Yes, to disturb the forest.
Yep, to knock things over and move things around, and as an elephant would, they actually they landscape.
Yeah, absolutely.
Yeah.
And big herbivores, right, they eat lots of plants, they walk far distances, and so they're really efficient at spreading these, what they're eating gets dispersed quite far.
Yeah, and digesting slowly, so it's not,
Yes, it takes a while.
Walk and just keep dropping all along the way.
Indeed.
Very cool. So, my next news article is not about dinosaurs. But,
That's okay.
Yeah. But these animals shared the planet with dinosaurs. This is about an ichthyosaur.
Woohoo!
Yeah, these are cool animals. We haven't actually talked about these, I don't think yet.
Yeah, I don't know that we mentioned ichthyosaurs at all.
Which is a shame because they're awesome. They'll get their love at some point.
Absolutely.
Ichthyosaurs, just for anyone who might need a refresher or might not be 100% sure which animals these are. These were marine reptiles alive during the age of the reptiles, during the age of the dinosaurs.
Mm-hmm.
Very, very prominent. They were one of the main predators in the oceans. They ranged in crazy amount of size from very, very small ones to truly enormous, 20-meter long, individuals. So very cool animals. They look very much like a reptile's answer to a dolphin or shark.
Yes.
Very torpedo-bodied, angular, triangular fins, a semicircle, crescent tail, oriented like a shark's, not a dolphin's, but then they have a very long, needle-like snout.
Yes. Sort of like a reptilian swordfish.
Yes, yeah, exactly. And like I said, though, they ranged in size and they also ranged in diet. We see lots that were going after fish and soft-bodied animals, but some were going after tougher stuff, which is what it seems like this specimen was going after. Now, this is a newly discovered specimen in India, and the research was published in PLOS ONE by Prasad et al. I hope I'm pronouncing that name right. But they discovered this ichthyosaur, a big one. It's about 5.5 meters long, just shy of 20 feet. So it's a sizable animal.
Yeah, that's not small.
Yeah, and it was found among ammonites and belemnites, which we talked about in our cephalopod episode.
Yeah.
The very squid-like, but still hard pieces, still with hard pieces. And the teeth of this ichthyosaur suggest that these animals were probably some of its food sources, as it had the tooth wear showed that it was going after tough food.
Cool.
And all of that's super neat. The reason this stands out is it's a very complete specimen, and it's one of the first complete ones, ones of this complete from India, but it also is the first Jurassic ichthyosaur found in India.
Very neat.
Yeah, so it's the first specimen from that age in this area of the world, and that's anytime you find something like that, that's can be a big moment because it opens up a whole new chapter for those animals.
Yeah.
Confirming that they were around in that area that time, and could lead to explaining a lot more because it's from what they see so far is a new genus could reveal answers about the lineage and evolution of ichthyosaurs in general, since this is potentially going to be a very new and potentially very different since we've never found one from this age in this place.
That's exciting. It's
Yeah.
especially exciting because it can reveal patterns of movement for the ichthyosaurs. Like a new species is always exciting because it reveals patterns of evolution.
Yeah.
But we call this a range extension,
Yes.
right? When you find something in a place or at a time that it's never been found before, you're extending the known range of that group of animals. And that tells you all sorts of cool new stuff about where they were living, where they were moving over time, how long they were spending in different parts of the world, which is really good information to know.
Absolutely. I mean, that's stuff that we have to do with modern animals all the time. Is if you keep up with just general nature news, you'll hear all the time like, "Hey, we saw a coyote in this area of this state for the first time in 50 years, or for the first time we've ever recorded one." And if you keep seeing that stuff, well, then now we might have to adjust where we say coyotes are found because they may have moved or something may have pushed them or what may have happened. And this is the equivalent, but for fossils, which is very neat.
Yes. Actually, my second news piece has a range extension as well.
What?
How about that? My final news piece is related to dinosaurs, not at all.
Oh.
Unless you're watching movies from like the 50s.
I mean, the Flintstones.
This is a study about the genetics of saber-tooth cats. We're off to a good start.
Very cool.
Yeah, no, it's good stuff.
Yeah, no, that's awesome.
This is a study by Johanna Pijmans et al. In Current Biology. I hope I said that correctly. Johanna. What they did is a genome analysis on the ancient DNA of Smilodon, which is the saber-tooth cat from over here in North America, one of the later ones, and Homotherium, which is another cat that lived in both Europe, Asia, and then over here in North America as well. This is one of those studies that is interesting because it's hard to find a single aspect to focus on, because what they did was they did the genetic survey that found a whole bunch of interesting points to mention. For starters, they were able to calculate the relationship, right, the divergence, the ancestral split between these two types of saber-tooth cats, and found that they diverged way back 18 million years ago. Right? This is molecular clock dating, figuring out how long it took for those genetic differences to build up. This is interesting because that's longer ago than the split between all modern cats.
Oh, wow.
So these two were separate from their ancestors for longer than any living cats have been, which is actually really interesting.
Very cool.
It also placed both of those saber-tooth cats outside all of modern cats. So they're still cats, right? They're still felids, but all living cats are closer related to each other than these cats are. And than they are to these cats, I should say. And they split from living felids, according to this study, back around 20 million years ago.
Wow.
So that was the beginning of this divergence between these saber-tooth cats and the modern lineages of cats. And then shortly after that, the Homotherium and the Smilodon line split from each other as well. And then they both persisted all the way through the Pleistocene. But there are two species of Homotherium, generally recognized from later in the Pleistocene, in Europe and in North America. But the one in Europe, in Eurasia, disappears in the Middle Pleistocene, around 300,000 years ago, except for one specimen.
Ooh.
There is one specimen known from the North Sea, which appears to be Homotherium, but it comes from about 30,000 years ago.
Oh, wow.
Right at the end of the Pleistocene. And it was identified as Homotherium, and people were very confused by it, because there's a huge gap there that were missing this fossil information for more than 200,000 years.
Mm-hmm.
This study looked at it again with the molecular data, right? Looked genetics and corroborated the identity and the age of that fossil. They're saying that is indeed Homotherium, and it is indeed from a couple 100,000 years later than the next youngest Eurasian Homotherium.
Wow.
Which is really cool. That's a heck of a time extension.
Yeah, that's a big jump.
And they were suggesting, right, so obviously it could be that we are just missing fossils, right? These are not particularly common fossils necessarily anyway.
Mm-hmm.
So, maybe we've just missed them in that time frame.
Yeah.
But this study also found that the New World and Old World Homotherium are much more closely related to each other genetically than has previously been realized.
Interesting.
And they suggest that one of the reasons for that close connection might be that during all of this time, there was still a migratory link.
Mm-hmm.
That it wasn't that one group went to North America and one group stayed in Eurasia and they stayed separate, that they were remaining genetically similar because they were connected either through migration or through near, close living populations that were still exchanging genetic material. And if that's the case, then it might be that this super late Homotherium over in Eurasia, it could be that they were there the whole time and we're just missing the fossils. It could also be that they actually did disappear and then some migrated back over.
Interesting.
Far later.
Much like horses here in North America, where they were here, went extinct here, and then were reintroduced.
Yes, and we brought them back over. So, some really interesting... It's one of those great studies that answers a couple of interesting questions and then raises a bunch more.
Mm-hmm. Mm-hmm. Very cool. That's... Whenever I studies like this pop up, I always look at them like an overlay. Like if you had a map and then you were able to put those cellophane things you can put over it, that like this one has the roads, this one has the rivers, this one has the entertainment stuff. It's like you can put that, but with these studies, you put it on and it fills in a lot of stuff in the map, but then it also it runs over the edges onto where there would be other maps.
Yes.
But you don't have those maps yet.
Nope.
And that's the cool. So it brings a whole lot of information in, but now brings up these avenues that you didn't even know that was a question that you needed to ask.
Yeah.
Which is really cool.
Yeah. So now there's more questions to ask about saber-tooth cat dynamics in the very late Pleistocene.
I love... I think my favorite part of it all was discovering how long ago they diverged. Like that's very interesting.
Yeah, they split way back. That's like... That implies that Homotherium and Smilodon split earlier than humans and orangutans.
Yes.
That's a deep split.
And it's interesting, and it seems counterintuitive because they look similar in the fact that they're both recognizable as saber cats, like saber-toothed cats. But, that does not mean that they have to be closely related,
Indeed.
That can be very misleading.
Yes.
Cool.
And that's the news.
Tune in next time.
Tune in next time for more news from the news.
With the news.
And now, let's talk about dinosaurs.
Dinosaur.
So, today we are talking about dinosaurs. Not a specific type of dinosaur, dinosaurs the group.
Yeah.
So this is going to be an introduction, a flyby overview of dinosaurs. We're not stopping. It's going to be like in Jurassic Park 3, we're going to fly over the island.
Mm-hmm.
We're not going to get close, because if we go down and we land and we get up close among the dinosaurs, the danger there is we end up in a really bad movie.
Yep.
So, let's start with, what are dinosaurs? What is a dinosaur? I think one of the biggest confusions that comes up, especially in the public image of dinosaurs a lot, is that dinosaurs are just animals, but they're not often portrayed as just animals.
Yeah.
Right? They have a definition, they have specific traits, they have diversity, they evolved at one point, lots of them went extinct at different points. Dinosaurs are archosaurs.
Mm-hmm.
The archosaur, in part of the reptile family tree.
The best part.
The best part of the reptile family tree? Wait a minute. No. The second best part of the two major branches.
The best legged portion.
All right, sure. The archosaurs include two major lines, the croc line and the dinosaur line. The dinosaur line also includes the pterosaurs, the flying reptiles, and a bunch of very closely related dinosaur-like things. Dinosaurs are united by a handful of particular traits. A lot of them actually have to do with their locomotion. Dinosaurs hold their legs directly under the body, the same way mammals do. This is called the parasagittal stance. Dinosaurs are digitigrade, which means they walk on their toes. Not on their tiptoes, but on the balls of their feet, like cats and dogs do.
Yes.
They have a unique hinge joint in the ankle that is specific to dinosaurs. They have a hole right through the middle of their hip bones. They have particularly long lower legs and foot bones, which are actually something that pterosaurs share as well.
Yeah.
Altogether, these things suggest a particular kind of locomotion. These are traits that allow dinosaurs to walk the way they do. These are great traits for efficient locomotion.
Yeah.
Some of them are probably really important for supporting a large body. Some of them are very important for walking bipedally on two legs. There are other aspects as well that dinosaurs have. They have the S-shaped neck that all the animals on the dinosaur half of the archosaur family tree have. They have a particular shape to the humerus. They have, ancestrally, all dinosaurs have grasping hands, which is very... some of them held onto it, some of them modified away from it.
Very interesting.
Yes, it is. These are... And then there's more, right? There's skull features. These are specific skeletal features that define dinosaurs.
And the cool thing about a lot of those definitions is, and you know, as you said, they often get treated as animals. All groups of animals have definitions like these.
Yes.
Features that make them a group, not just the fact that they're named the same thing. There's something specific that groups them together. And a lot of these features are actually the same ones used for the croc line, but on the opposite side of it. You know, the ankles and the legs and hip joints in crocs are a big part of how they're identified.
Yeah.
Because they're different.
Yeah.
And so that's one of the reasons those traits are there, is that they're similar except for the things where they're able to be defined as separate.
Yes. Like we talked about in episode 10, we define groups of life by their traits and their ancestry. The ancestors of dinosaurs evolved these traits, and all dinosaurs inherited them. It's interesting to compare them with things like mammals, because mammals are defined, and a lot of living animals are defined by a lot of things we can't tell in fossil creatures. Like mammals are defined in part by mammary glands.
Yep.
And
what mammal is.
Yes, mammals, mammary glands. And fur. And certain physiology, right? Mammals are a particular type of warm-blooded. It's hard to tell those things in dinosaurs and extinct creatures, so the definitions tend to be more esoteric features of the bones.
Yes. Very specific skeletal features, usually.
Yes. But the things you can imagine, right, when you picture a dinosaur are the way that they walk on their toes, the way that their legs are directly under the body. This also means that there are lots of things that are not dinosaurs.
Most things.
Hollywood and toy companies and everybody. Pterosaurs, the flying reptiles of the Mesozoic, not dinosaurs. They share ancestry with dinosaurs. They actually have a few features in common because they're so closely related. But they don't have that combination of features. They don't have those leg traits, and they don't have that ankle joint. They are separate.
Yes.
Crocodilians, also closely related. They're archosaurs. They have a lot in common. They do not have the dinosaur suite of characteristics. The oceanic reptiles, mosasaurs, ichthyosaurs, plesiosaurs, not even close.
Yeah.
Those are a whole other part of the dinosaur family tree, of the reptile family tree, separate from the dinosaurs.
Much closer to other reptiles, but nowhere near the archosaurs.
Yes, mosasaurs are on the better half of the reptile family tree. In
The
fact,
longer half.
the long, yes, the stretchy half.
Yes, the very slender half.
Well, it's not maybe not necessarily the longer half.
Yeah, no, that's true.
More on that in a bit. And shout out to our longtime friend, poor Dimetrodon.
Yeah.
If mosasaurs aren't even close to being dinosaurs, calling Dimetrodon a dinosaur is like calling a bicycle a car.
Yep.
So Dimetrodon is that sort of sprawling, lizardy-looking dude with a big sail that came from the Permian
Comes
period.
in every little packet of plastic toy dinosaurs. It scared Littlefoot and Land Before Time. They show up all over.
Yes, it did. Didn't even live during the Mesozoic.
Nope.
Died before the dinosaurs ever showed up.
Yes.
And is a mammalian ancestor. Well,
Yeah.
ancestral relative.
Yeah, so these were reptilian in appearance, but not actually a direct connection, so
Yes.
very different.
So dinosaurs have a definition. And this is something I always try to stress to, especially like students or kids when I'm teaching about dinosaurs and stuff. It's not just, it's not just a word we assign to any big scary thing from the past. There's a specific use for that term. And that specific use is very important because it allows us to communicate about them.
Well, and it's because we get so used to, everyone roughly knows what dinosaurs are because they've seen dinosaur shows and movies. Everyone knows what a bird is because they see them all the time. So you don't have to define birds. Okay, yeah, but I can look at it. It's a bird.
Yes.
But all groups have these definitions. It's why sharks are fish. People always talk about fish and sharks, but sharks are fish. They're just a specific grouping of the fish.
Absolutely.
And so it's easy to forget that there is science behind the name.
Yes. It also doesn't help that dinosaur has become a word.
Yeah, an adjective.
Yeah, that we use it to refer to things that are old and outdated, which is also an unfair comparison to dinosaurs.
Yes.
As we'll see. Dinosaurs lived during the Mesozoic era.
Yeah.
We talked about the geologic timescale back in episode 12, and then also in that special digression episode.
Yeah.
Dinosaurs show up in the Mesozoic. They persist from the Triassic, through the Jurassic, through the Cretaceous, and some of them make it past the Cretaceous into the Cenozoic. But the biggest diversity of dinosaurs is throughout the Triassic, Jurassic, and Cretaceous periods. And so that is where our setting is as we take a tour through dinosaur diversity.
Yeah.
So, we're going to make our way through the dinosaur family tree. We're going to go quick stops at the major groups and talk a little bit about dinosaur diversity because it's really difficult. Everybody wants to talk about dinosaurs and make general statements about dinosaurs.
Yeah.
And that's really hard to do because dinosaurs were super diverse. They were around for an incredibly long period of time. Through the Jurassic and Cretaceous, dinosaurs dominated landscapes around the world. They were the top terrestrial organisms on the planet, and they occupied all sorts of different niches.
It's the same reason as what you said earlier with the definitions that make a mammal are fairly odd. Like, fur and mammary glands are two of the ones that you can apply to every mammal. But a lot of the things that you think of being mammalian, you can't apply just to everyone because you have some egg layers. You have some like the naked mole rat, which seems to have lost its endothermic ability, and so you get someone so you can't just paint it with a brush that dinosaurs were large reptilian, animals that dominated the landscape. It's like, some were, these features that you're saying, plenty were very different.
Yes, they're not defined as being big. They're not defined as being scaly. They're not even defined by those grasping hands. That's a feature they started with, but a lot of them shifted away from it.
Yes.
So let's take a tour through the dinosaur family tree, starting with the first major group, and we're going to miss a lot because we're going to do this broad strokes because there's a lot of them. The first major group that we're going to talk about are the Thyreophora, the armored dinosaurs.
These are some of the cool ones.
Yeah, the armored dinosaurs come in two varieties, the Stegosaurs and the Ankylosaurs.
Yeah.
Both of them are groups composed of quadrupedal herbivores.
Mm-hmm.
Four-legged, plant-eating, entirely or mostly plant-eaters.
Yeah.
And what they share, the big feature that they all share, is abundant osteoderms.
Mm-hmm.
Osteoderms are bones that grow in the skin. Crocodiles have them, skinks have them, armadillos have them.
Mm-hmm.
It's natural bony armor. The two groups of Thyreophora sort of adapted their osteoderms towards slightly different purposes.
Took them to the extremes.
Yes, so in the stegosaurs, the osteoderms are specialized, and they show up in particular shapes in particular parts of the body.
Mm-hmm.
You imagine Stegosaurus. Stegosaurus has those huge plates up and over the back. Lots of other stegosaurs had those in different shapes and sizes. The African Kentrosaurus had the same thing, except they were spikes instead of plates. Most of them.
Kentrosaurus is my favorite.
Yeah.
Of this group.
A lot of stegosaurs also had spikes coming out of their shoulders.
Yeah.
And common throughout stegosaurs is a structure called the thagomizer.
Thagomizer.
Which are the spikes on the tail that stick out to the sides and form a mace, right? They have a weapon on their tail.
Mm-hmm.
All those things together suggest that these dinosaurs were engaging in active defense.
Mm-hmm.
Right? This is an enemy showed up, they would point the armor at the enemy. Right?
Yes.
Angle the back, the shoulder spike, the tail. This was an animal that had to act to defend itself.
Yeah.
Stegosaurs range in size, right? The earliest stegosaurs and the earliest ancestors of Thyreophorans were, tiny little, several feet long.
Mm-hmm.
The biggest ones, Stegosaurus, among the biggest ones, got to, we're talking the 30-foot long range and weighing as much as an elephant.
Yeah.
Right? Several tons. Big animals. Stegosaurs are from around the world. They show up in the early mid-Jurassic and become super common in the mid to late Jurassic.
Ooh.
That's the heyday of stegosaurs. And then once the Cretaceous sets in, they kind of fade away, and they don't make it to the late Cretaceous.
Yeah.
They are gone. The other group of Thyreophora are the ankylosaurs.
Yeah.
The stegosaurs specialized and honed their osteoderms to certain parts of the body. The ankylosaurs put osteoderms everywhere.
Everywhere.
Everywhere you can think to have an osteoderm.
Eyelids.
They've got them all over the back. They've got them on the tail, on the skull, on the neck. Some of them have them on their legs. Some of them have them on their bellies. Some of them have them on their face.
Mm-hmm.
Some of them had them... I think I mentioned everything. Maybe I didn't. Who knows? They had them all over the place. They had bumps and knobs and spikes. The lab at Adelphi, where I hang out a lot and help out, volunteer over there, get spikes from a dinosaur called Sauropelta from the shoulder. And these are huge, like longer than my forearm, spikes that just stuck out of the shoulder.
Mm-hmm.
Some of them had tail clubs, like Ankylosaurus itself from here in North America. But for the most part, and they also had very wide bodies.
Yeah, it's
to
like
other dinosaurs.
like an elevated turtle almost. Like the legs are underneath, but they've got that very half shell shape to their back.
Yes, they're tanks.
Mm-hmm.
Right, low center of gravity, wide bodies. Unlike the stegosaurs, these dinosaurs appear to be more passively defensive.
Mm-hmm.
That is to say, it doesn't matter what direction the threat's coming from; they just plop down, and they're good. Right, nothing's gonna hurt them. Except for the tail clubs, obviously, those are a bit more active in their defense. Unlike the stegosaurs, right, so the stegosaurs kind of peak in the Jurassic and then fade away. The ankylosaurs show up in the Jurassic, stay kind of rare, and then really hit their stride in the Cretaceous.
Nice.
And then they stick around all the way to the very end. They go from very small forms to the biggest ones like Ankylosaurus, which are about the same size as the biggest stegosaurs, right?
Yeah.
30 or so feet long, elephant size, several tons in weight.
Very cool. And one of the themes that a lot of people won't realize is when we're talking about the larger sizes, those will often be the names you recognize because those are the ones that it's more fun to make toys out of.
Yes, they're the famous
ones.
ones, and a lot of the time they're also the first ones studied.
Yeah.
Which is why the groups have their names. That's why the Stegosauria is named after Stegosaurus.
Yes.
Yep. Speaking of armor, the second major group of dinosaurs that we'll talk about are called the Marginocephalia. The Marginocephalia are herbivores. The Marginocephalia share, one of the big features they share, are these expanded bones in the back of the skull.
Mm-hmm.
Two groups took that and ran with it. One are the horned dinosaurs, the ceratopsians, and the other are the dome-headed dinosaurs, the pachycephalosaurs.
Yeah.
Ceratopsians start off, like all dinosaurs, very small.
Yep.
The Jurassic and early Cretaceous ceratopsians were small and bipedal, two-legged.
Mm-hmm.
Little dinosaurs like Psittacosaurus, who we mentioned before. Ceratopsians, even the early ones, had this beak.
Yeah, big parrot beaks.
Parrot beak that are characteristic of the group. The later ones, right, moving into the late Cretaceous, you started to get these big quadrupeds. Small quadrupeds and big quadrupeds. Small ones like Protoceratops, who are only, several feet long, all the way up to Triceratops and other huge ones who were, once again, elephant-sized.
Yeah.
Right? 10 tons or so, 30 feet long, somewhere thereabouts. The ceratopsians, especially the ceratopsids later on, turned those back of the head's skull bones into those huge frills.
The shield.
The big shield, and a lot of them had horns over the eyes, horns on the nose. Some of them had spikes around the edge of the frills.
Yeah.
They just had these crazily ornamented heads. Those heads were probably, right, defensive. They were probably for display. They remind me a lot of, if you think about cervids and bovids today, deer, gazelles, antelope, moose, bison, rams, just every shape of horn and antler you can think of.
Yep.
For both defensive purposes, for perhaps combat purposes, and just for showing off.
Yeah. Like there was some that had curled horns, there was one that had flat, like nose anvils, like weird things. And it's pretty crazy looking at them all.
Ceratopsians also had, right, they had, especially later on, right, they had that big beak. They had very complex teeth.
Yes.
Very great grinding teeth. And those frills, those big skull bones in the back, supported jaw muscles that gave them very powerful jaws. So good eaters.
Yeah. Grinding stuff up.
Yes. Their sister group are the pachycephalosaurs. Pachycephalosaurs are all bipedal herbivores. And what they did with those cool bones in the back of the skull, instead of the frill that the ceratopsians had, they had these sort of armored, bumps and spikes all around the edge of the skull.
Yeah.
And the top of the skull was a dome of thick bone.
Yeah, it's like swollen almost looking.
Yeah, these are the ones that you always see on TV butting heads with each other, which they may or may not have actually done.
Yes.
They had relatively small arms, comparatively. They are mostly found in the late Cretaceous of North America and Asia. And compared to the ones we've talked about so far, they stayed fairly small.
Yeah, yeah.
The smaller ones, like Stegosaurus, were the size of a medium-sized dog. Pachycephalosaurus is among the biggest, and it was, a bear-sized.
Yeah.
Maybe a ton.
About a tauntaun, if you're...
Yes, exactly. Maybe about the size of a tauntaun.
It's what I always picture them as, because they've got the same posture.
That's true, actually, yeah.
Uh-huh.
And they may even have been warm on the inside.
Yeah. They probably didn't smell any better, though.
Probably not. The next major group of dinosaurs are the ornithopods. The ornithopods are kind of weird to try to talk about because the ornithopods were crazy diverse.
Yes.
These were partially bipedal herbivores. Most of them could be bipedal, right? They were able to walk on two legs. They didn't always walk on two legs. These include the iguanodonts with their crazy thumb spikes, the duck-billed hadrosaurs. Many of them had crazy head crests, like Parasaurolophus and Lambeosaurus, with those weird, flashy crests on top of their heads. They ranged from tiny little things like Hypsilophodon to absolutely enormous. The largest ornithopods, like Shantungosaurus, was 40 or 50 feet long. and weighed perhaps 2 elephants. Big, big, big. These guys got quite large.
Yeah.
What they all have in common, or generally have in common, especially the more advanced ones, is these highly specialized jaws.
Mm-hmm.
Ornithopods were some of the best chewers in Earth history. A lot of them had broad mouths for gobbling up lots of food. Their jaws were very mobile. They had, especially in the more derived ones, thousands of teeth.
Mm-hmm.
Just packed batteries of teeth that made them excellent at grinding up all sorts of plants. Perhaps because of this, they're around in the Jurassic. They take off seriously in the Cretaceous. They lived everywhere.
Yeah.
All over the world, all sorts of different environments. They came in a huge diversity of shapes and sizes.
Yeah. If there were plants there, they were eating them.
Yeah, pretty much. They also had close relatives to the true ornithopods, depending on your taxonomy, are the thescelosaurs, which were very similar, small. These were small herbivorous bipeds like Thescelosaurus. Some of them were burrowers, like Oryctodromeus, which is ridiculous to think about and super cool.
Mm-hmm.
Altogether, another thing that the ornithopods share is that they have these specialized hands that have a combination of some of the bones are sturdy and pillar-like, and other bones are grasping and mobile. So these were good hands for if you needed to walk on them or if you needed to rear up and grab at trees and stuff.
Yeah.
So they were, in a lot of ways, these were excellent all-purpose herbivores.
Yeah, they were designed for general success, so that if you put them somewhere, they'd find something to eat and they'd get at it.
Yeah, pretty much.
And
they were probably delicious.
Oh, yeah. This was the steaks of the dino world.
Yeah. Those groups, the Thyreophora, the Marginocephalia, and the ornithopods, and their relatives, all together make up the Ornithischia.
Yes.
One of the big things that they share a lot of things, but one of the iconic features is that their hip bone, the pubis, points backwards.
Yeah.
Which is often inferred to be an adaptation for presenting more room for the gut for all that plant digesting. There's also another group, a smaller group, which is to say less diverse and also smaller in size, the Heterodontosaurs, which are small bipedal herbivores that have these weird teeth. A lot of them had these like tusk-like fang teeth, which is pretty cool.
It's like the what's the deer that I'm blanking on?
Oh, the saber-tooth deer?
Yeah, the saber-tooth deer.
Is it the musk deer?
I think it's the musk deer, yep.
That might be it.
Yeah.
No, they had those cool teeth.
Yeah, like a little musk deer.
Yeah, Tian Yulong, actually, the fuzzy ornithischian is a heterodontosaur as well.
Oh, cool.
The next group of dinosaurs, the next major group on our flyby, are the sauropods. Sauropods are characterized by a handful of things, right? Sauropods are the dinosaurs with the tiny heads at the end of the long, long necks.
Yep.
That end in big old bodies and then long, long tails. Littlefoot is a sauropod.
Yes.
The dinosaur that makes Dr. Grant fall on his butt at the beginning of Jurassic Park is a sauropod. Sauropods have air sacs through their vertebrae, just like birds do today. A lot of sauropods, especially the bigger ones later on, had these stump hands.
Yeah.
Where all 5 of their toes touch the ground, which is unique and a really notable adaptation for weight support.
Yeah, it's very, like if you look at an elephant foot and think it's pillar-like, these were very pillar-like.
Yes. Some of them even lost their fingers.
Yes.
Like evolutionarily, it's like they were like knuckle walkers. They just got rid of the fingers below the knuckles.
Yeah. What are we using these for? Get rid of them.
Don't need them. Just need to stand on this. They were highly adapted in many cases for bulk eating. Right? They had very simple teeth. They had wide mouths, so they were just gobbling up a bunch of trees and swing that long neck to as many trees as you can reach. Pile all the plants down your throat. Right? They weren't doing a lot of chewing, many of them. all the digestion, and they would swallow rocks. We found gizzard stones
Yep.
associated with them. They'd grind them up in the gut so they could keep moving and keep eating.
It's like the hose attachment for a vacuum cleaner.
Yes. Probably the most famous thing about sauropods, the most famous trait of sauropods, is that they are gosh darned enormous.
Huge.
The largest dinosaurs we've talked about so far were elephant size, right? On par with the largest land mammals of all time.
Yeah.
Right, the big mammoths and elephants, right? In that sort of 10 to 20 ton range at most.
Mm-hmm.
That is standard to small for a sauropod.
Yes.
Sauropods regularly hit 50 feet, 60 feet, 70 feet long, estimated at 10, 20, 30, 40 tons. The biggest sauropods weighed as much as a family of elephants. Huge, like Argentinosaurus and
Yes.
Patagotitan are estimated to be well over 100 feet long, snout to tail tip, and, as much as 60 or 70 tons.
Yep.
When people talk about dinosaurs being big, right? Yes, there were lots of big dinosaurs. For the most part, they weren't ridiculously huge.
Mm-hmm.
They were on par with giant mammals, for example.
Yeah, or there was just a couple species that
Yes.
pushed that limit.
Sauropods were walking whales.
Yeah.
It's insane how enormous they got.
Mm-hmm.
They were also some of the most successful dinosaurs.
Yeah.
Sauropods actually rose to dominance. The earliest sauropods became dominant in the Triassic
Yeah.
and then stayed there. They were we used to think that sauropods kind of peaked in the Jurassic and then disappeared,
Yeah, petered out.
but they didn't. We have since learned that all the way to the end of the Cretaceous, sauropods were dominating landscapes.
And still big.
Yes, still huge. Some of the biggest ones come from the very end.
Which is really cool.
Yes.
They're one of those dinosaurs. Like, this happens with tons of dinosaurs, and we'll get into this, when we talk a little bit later, but where it's hard to think, how exactly was this animal living because it was such a weird shape or it has like a really weird feature.
Yeah.
These are one of those where it's really tough. And, simple questions like, how are they making babies?
Yes.
Are really complex questions when you're dealing with something this size.
Absolutely. And we should stress that, we tend to characterize these sorts of dinosaurs, especially ornithopods and sauropods, as sort of a one-form-fits-all.
Yeah.
They weren't. The sauropods were insanely diverse.
Oh, absolutely.
All over the world, tons and tons of different species. A lot of them overlapped, living alongside each other.
Mm-hmm.
Just all sorts of different versions of that sauropod body form.
Yeah, you get a lot of rearranging of the position of the neck, where it's out long and flat at an angle, almost straight up and down like a giraffe.
Mm-hmm. Perhaps that's one of those big questions for a sauropod episode.
yes, this is true. But it's you get different positioning.
Oh yeah, the skulls shift a lot.
Mm-hmm.
Yeah, there's all sorts of diversity in there. Speaking of diversity, the final group of dinosaur, the final major group, are the theropods. The best group.
Yeah, most people's favorite.
Yeah, my favorite.
Yep.
Yeah.
The one that should be your favorite.
The theropods are the bipedal carnivores, mostly. These are the meat eaters. Theropods walk on 2 feet. They have big, grasping hands most of the time. Most of them have knife teeth. These are serrated, blade-like teeth. They have big hip muscles. They have 3-toed feet, right? Classic 3-toed footprints. They've got flexible jaws for grabbing onto prey. These are, crested Cryolophosaurus, croc-faced fish-eating Spinosaurus, bone-crushing Tyrannosaurus, right? The ornithomimids, which were like ostriches and were probably eating plants or having an omnivorous diet.
Yeah, eating bugs.
Yes. The dromaeosaurs, like Deinonychus and Velociraptor. Small, totally feathered, long, powerful arms, sickle claws. Theropods were hugely diverse.
Yes.
Theropods from the start, right? They rise to global dominance in the early Jurassic, and they survive all the way to the end of the Cretaceous, dominating their environments the whole time.
Yeah.
And they are the only group of dinosaurs that left survivors after the KPG extinction. Among those diverse groups of theropods were birds. The earliest birds show up in the Jurassic, and they live alongside their dinosaur relatives all the way until the end of the Cretaceous. In fact, a lot of the features we usually think of as bird features are just theropod features.
Three-toed feet.
Three-toed
flexible
feet.
jaw.
Yep.
Yep.
Feathers were very common in theropods. All theropods had air sacs in their, at least in their vertebrae. All theropods had those fused collarbones into a single bone called the furcula, or the wishbone.
Yep.
These are, right, birds are fit right in, they're nestled right in there with the diversity of the rest of the theropod dinosaurs.
Yeah, it's extremely successful group.
Yeah, and man, there's so many. I don't think we could even do theropods in a single episode.
No, that one would be tough because, like, when you say theropod and you say the two-legged predatory dinosaurs, you're like, oh yeah, the big ones like Allosaurus T-Rex, the little ones like Velociraptor, Deinonychus. But it's so easy to forget about the ornithomimids, which have their own huge range.
And the oviraptorids and the therizinosaurs and that everything you just mentioned are coelurosaurs.
Yep.
And not even, Allosaurus and Carnotaurus and Coelophysis and Dilophosaurus and oh my goodness. And their size range, right? These, the smallest non-bird theropods were chicken-sized, sparrow-sized.
Yeah, it's smaller than most of your house pets.
Yeah, and the very smallest theropods of all time is the bee hummingbird. Super, super tiny.
Yep.
And then the largest theropods were, stop me if you've heard this one before, roughly elephant-sized.
Yep.
T-Rex, Giganotosaurus, Spinosaurus. These were big, right, 30, 40 foot long, maybe, several tons in weight.
Yeah.
Traditionally, sauropods and theropods are grouped together in a major group called the Saurischia, sister to the Ornithischia on the other side. That has recently been called into question, as we discussed in our first ever digression on Ornithoscelida. Whether or not that takes off, we'll see. But for now, those are the major groups.
Yes.
Those are your dinosaurs, particularly through the Jurassic and the Cretaceous. The armored dinosaurs, the horned dinosaurs, the dome-headed dinosaurs, the long necks, the ornithopods, the theropods. That is a taste of this incredible diversity that dinosaurs achieved during their reign on the planet.
And I think that's a thing, is to mention, since we've gone over the diversity a bit and the range of their time here, is dinosaurs were around for a long time.
Yes, that is a good point.
They were global, and they were not, this isn't like saying the history of cats, which is a small subset of mammals.
Yeah.
This would be like very much like talking about the history of mammals, including everything from flying bats to swimming whales. The dinosaurs are a very diverse, long-living group, and you get, within each of those, you get, we could do multiple episodes per each of those groups.
Absolutely.
And still only be scratching the surface. There's a lot in there.
Yeah. And I think that there is this tendency for us to think about dinosaurs, in the public eye especially, as a failed group.
Absolutely. Yeah.
Right. And that, again, these were the dominant carnivores and herbivores of just about every terrestrial environment for at least 100 million years.
Yeah.
If you're being generous, like if you're being very strict, it's 100 million years of this global dominance that, they came in all sorts of shapes and sizes. Old ones went extinct, and new ones rose and took their place. They didn't disappear. They only disappeared after one of the worst global calamities in Earth history.
And it's good to remind everyone out there and all of our listeners that is longer than our group has been dominant.
Oh, yeah.
We still have
way longer.
Over 30 million years to go
before we can catch up. To catch up to that.
And who knows what might happen in that time.
And in fact, that's longer than any other terrestrial group, really. Nothing else has achieved that duration. And even that's a little unfair because they were so diverse. Mm-hmm. Right? Again, like you said, it's like talking about mammals. Mm-hmm. It's like saying, hey, what's cool about mammals? Oh, boy.
Yeah.
Have a seat for 15 weeks and I'll give you a rundown of what's cool about mammals.
You can pick one a day and we'll talk about it.
Yes. So they were a really impressive group, and they still are.
Yes.
Which is another thing to keep in mind. There are twice as many dinosaur species on the planet today as there are mammals.
Yep.
Birds outnumber mammals by at least a few thousand.
Yeah, they've lost the sizes that we found so impressive and that we see in our mammals today, but they've not lost the diversity.
No. And they're still major herbivores, major carnivores. They're doing great.
Terrestrial, burrowing.
Yep. Yeah, the age of dinosaurs has not ended. They're still doing great.
What this really is the build up to the Quentin Tarantino style rise of the dinosaurs as they take back the
resurgence.
This is the dinosaur propaganda.
Dinosaurs 2. The flappening.
The flappening. There you go.
Oh, I just thought of that. I'm sure I'm not the only person that's thought of that, but I just thought of it. It's mine. So that's dinosaurs, right? That's dinosaurs in their extremely long and successful heyday. Mm-hmm. But let's go back to the beginning.
Yeah.
Where did they come from? Everything comes from somewhere. Dinosaurs first evolved in the Triassic. Mm-hmm. When they started, they were not exciting. Or at the very least, they were not as comparatively exciting in relation to all the things that were around them.
As is true with most groups in their early days.
Yes, exactly. Like most groups, they started out as a handful of a diversity of more minor players in the field. Mm-hmm. During the Triassic, there were a bunch of different groups of what are called dinosauromorphs. This is right, remember when we talked in episode 2 about crocodilians?
Yeah.
You have the crocodilians, and then their more distant cousins are the crocodilomorphs.
Yeah.
Dinosaurs belong within this group called the dinosauromorphs. During the Triassic, you had the lagasuchids, the silosaurids, the lagarpetids, which were this variety of animals that were very dinosaur-like. Yeah. Right? They had the slender, long legs. They had that S-curved neck, generally. They were bipeds. They were quadrupeds. They were small. They were large. The early dinosaurs showed up among that company.
Yeah.
The very first dinosaurs, the oldest dinosaurs we have in the fossil record, go back to about 230 million years ago in the Triassic period, way back. The earliest dinosaurs show up in Brazil, Argentina, India. They appear to show up in the southern hemisphere first, which is interesting. Mm-hmm. Early dinosaurs fit right in with those other dinosauromorphs. All early dinosaurs were relatively small, right? Several feet long, maybe.
Yeah.
Two-legged, with grasping hands.
Yeah.
That was all that diversity that we talked about just now. All of them started out as small, two-legged, graspy-handed little dinosaurs.
It was a working model to begin with.
Yes. And they weren't dominant. Partially, mostly, because the Triassic was also the time of the Pseudosuchians.
Yes.
The crocodilomorphs, the crocodiliforms, and all their crazy croc-like cousins and ancestors and relatives. We talked a lot about them in the episode 15 when we talked about the Triassic. We talked a lot about them in episode 2 when we talked about crocs.
Yep.
Croc things ruled the Triassic.
They filled the big predator niche pretty thoroughly at that time.
Yeah, and so dinosaurs, they were a small part, a cog in the wheel. Mm-hmm. They were a fairly small piece of the global ecosystems at that time, kept in their place by those dirty croc creatures. Yeah,
it was a point in time where the chances were swinging either way with who was going to take over, and the crocs made their move first, and it was just not enough.
Yes, at the end of the Triassic, right, when that big extinction happened, almost all those croc dudes disappeared. Mm-hmm. Most of the mammalian relatives, some of which were pretty prominent back then, the therapsids, disappeared. The dinosaurs rose to take their place. But before that, during the late Triassic, what we had were a diversity of the very first theropods, like Demonosaurus, Chindisaurus, Camptosaurus, Coelophysis was back then, right? These were all relatively small. They were theropods, right? They had the bladed teeth, they had all the things. They were small. They were not dominant in their ecosystem just yet. Basal sauropod ancestors, right? Sauropodomorphs, which were small bipedal plant eaters, same size, just eating plants. Some of them were omnivores. Things like Eoraptor, which is named Eoraptor because originally people thought that it was, I believe, a theropod ancestor. Saturnalia, Panphagia. There were the Herrerasaurids, which are a lot like theropods, but not quite theropods. And then there's a bunch of dinosaurs from back then that we're not really sure where they fit. Just like the origin of any group, it's very difficult to, when everything's just getting started, it's really hard to say, all right, these are the first theropods, these are the first ornithischians, these are the first sauropodomorphs. The farther back you go, they converge.
Yeah, they start getting more and more similar.
Yep. The only exception to the dinosaurs didn't rule the world yet rule are the sauropods. In the late Triassic, those tiny sauropodomorph ancestors gave rise to what are commonly called the prosauropods. These were still bipedal, right? Long neck, tiny head, but generally walking on 2 feet, but they were big, right?
Yeah.
These were, 20, 30 foot long, at least a few tons probably. Things like Plateosaurus and Euskellosaurus. They, by the end of the Triassic, had already achieved worldwide herbivore dominance.
Yeah.
The sauropods were the first dinosaurs to really get that foothold and stake their claim as dominant terrestrial organisms.
Which is really cool because much like how the early dinosaurs were very theropod-like, the fact that they took hold very early on means those body designs, much like when we talk about any long-lasting animal, the reason that crocs are still shaped very much like animals, and their ancestors were in a lot of senses, that body design, evidently a really good one.
Yeah.
Which is cool to me. That's a successful, design for more than just a few circumstances.
Absolutely. And then the extinction happened.
Womp womp.
The end Triassic. Go back to episode 15 for details.
Yep.
Almost all those dinosauromorphs, right? The non-dinosaur dinosauromorphs disappeared. A lot of the croc things disappeared. A lot of the therapsids disappeared. And that, right, once the world was finished recovering from that extinction, that was when the dinosaurs began to really diversify and really take off.
Yes.
To fill all the niches that they ended up filling. All dinosaur, right, the earliest members of all those major groups were still those little bipedal guys.
Yeah.
Like Psittacosaurus is a good approximation of the earliest ceratopsians, which actually looked a lot like tiny pachycephalosaurs without the dome heads.
Yeah.
Right, very similar. Scelidosaurus is a small, lightly armored ancestor to the Thyreophorans. So they're those tiny beginning bipedal forms persisted to give rise to all that diversity we talked about.
Yes.
So the dinosaurs slowly rise to power, and and throughout the Triassic, take off through the Jurassic and the Cretaceous. At the end of the Cretaceous, of course, KPG mass extinction, episode 5. Everybody but the birds disappears.
Yep.
For the rest of the episode, what I'd like to kind of hit upon are some of the ways in which dinosaurs are weird.
Yes.
They're weird animals. They're very weird reptiles.
Yes.
And in fact, I hear a lot of people, when I talk about dinosaurs, will say things like, well, the dinosaurs, are they even reptiles? Do they count as reptiles? Now, that is a taxonomy question.
Yes.
Which, episode 10, let's not get into that. But the reason that comes up is because they're super weird. They're really bizarre. So we have learned quite a bit about dinosaur biology, lifestyle, and physiology. We could fill a whole podcast about that as usual, but a couple of the big points that I want to mention Many of them relate to one of the most common questions that people like to ask about dinosaurs, both professionally and non-professionally. How warm were dinosaurs?
Yeah.
Right? Warm-blooded or cold-blooded?
Mm-hmm.
Typically, right, we think about, right, warm-bloodedness is associated with birds and mammals.
Yeah.
High metabolism, active lifestyles, stable, high body temperatures.
Eating a lot.
Dinosaurs are interesting because there's a lot of evidence to suggest, even before you get into the, cutting up the bones and stuff, that these were active, like large-bodied, eating lots of food, advanced social structure. Some of them we know had parental care.
Yes.
Right? They had nests where they took care of their babies, which are characteristics you normally see with modern-day warm-blooded animals.
Mm-hmm.
On the other hand, they have a lot in common with other reptiles, right?
Yeah.
So in a lot of ways, dinosaurs seem like they don't necessarily seem like they were definitely warm-blooded in the same way that birds are, but they don't look like they're cold-blooded the same way that snakes are.
Yeah.
This has been investigated. We've actually gone from the theoretical to the cutting up the bones and taking a look. The direct evidence so far, looking at isotopes within dinosaur bones, which can be proxies for body temperature, suggests that all across their lifespans, certain dinosaurs at least had not only high body temperatures compared to the surrounding environment, but stable body temperatures.
Which is important.
That's a hallmark, yep. Consistent. They were maintaining body temperatures.
Because anyone who has ever had a fever or experienced hypothermia knows that when your body temperature changes and it's not supposed to, it's bad.
Yes. Yeah. Well, cold-blooded animals, right, poikilotherms, fluctuate their body temperature.
Exactly.
Examination of the microstructure of bone also reveals that the blood vessels have shapes characteristic of high blood flow.
Yeah.
In certain studies, which show
pumping hearts.
Yep, indicates high energy, high metabolism. So we've got that sort of direct evidence of high body temperatures, stable body temperatures, warm-bloodedness. But in a lot of cases, those sort of features end up falling between what we see for things like crocodilians and things like birds. One of the other challenges with trying to characterize the bloodedness of dinosaurs is two, warm and cold-bloodedness are not points, they are a spectrum.
Yes, and that does not typically get covered.
Yep. And two, yes, I know, dinosaurs were crazy diverse.
Yep.
It is very possible that certain dinosaurs were more or less warm-blooded, that exhibited more or less of these features.
Absolutely.
And that's really hard to know.
Well, it's crocodilians have been studied for that reason because they are true, ectothermic cold-blooded animals. Most of them, at least the ones that are in temperate environments, stop eating during the winter months. Alligators go 3 months out of the year where they just stop eating because it's not warm enough for them to digest stuff.
Yeah, and they don't need that much food.
But when studies have been done and thermometers put inside of crocodiles, swallowed and the internal temperatures measured over long periods of time, they've seen that they can actually achieve warmer than expected temperatures much more easily than you would expect just a typical reptile to do because they have so many adaptations to do it. So they are not warm-blooded, but they're much better at being cold-blooded than a lot of other reptiles are.
Yeah, and there's lots of that. Right? Great white sharks maintain body temperatures sometimes.
Yeah, with their
some
muscle
snakes,
movement.
Yeah, and then there's the issue of being big, something called gigantothermy.
Yeah.
Which is the simple principle that when you're big, you hold on to heat better.
Yep.
So like sea turtles. Big sea turtles tend to be fairly warm. They don't have to do anything to maintain that temperature. They're just gigantic, and so the heat doesn't disperse very quickly.
Yep.
So big dinosaurs maybe they were gigantotherms. Maybe they were warm-bodied just because they were huge and they didn't need warm-blooded adaptations. It's a difficult question to answer because there isn't a quick one-sentence description. Aside from they were diverse, they probably had a diversity of different points along that trait spectrum.
And that's the issue that a lot of people don't realize, is that it is a spectrum. It is not an A-B option.
Yeah.
You can have varying amounts of it. So even though most animals that you think of can be put pretty easily into they keep themselves warm or the sun does.
Yeah.
Like, even though that's what's normal today, it could have been common for dinosaurs to be something that we're not used to seeing.
Yeah. And that's honestly what my answer would be. If I were pressed to give a quick answer, I would say dinosaurs were probably, generally, warm-blooded, but not necessarily the way that birds and mammals are.
Yes.
They probably were doing their own thing.
Yeah.
Another thing that ties into this is growth rates in dinosaurs were crazy high.
Yeah.
Which is another feature we see in birds and mammals, and less so in reptiles. Dinosaurs grew really fast. We do studies where we cut the bones and we examine the growth patterns, the growth lines within the bones, and we can develop growth curves. And I'll put this on the blog post. The growth curves for theropods, especially like T-Rex, are fantastic.
Yeah.
Because they're like slow at first, then a growth spurt through the teens in T-Rex, and then plateaus again.
Yep.
They grow just like we do.
Yes.
Slow, then fast, then slow.
Yep.
Even the biggest dinosaurs achieved their size within a decade or two, which is not what you see in animals like crocodilians necessarily, or snakes necessarily, or tortoises, right? These are generally slow-growing animals. Fast growth is another indicator of high metabolism.
Yeah, and think of puppy growth,
Yes.
It used to baffle me when I was a little kid with birds and puppies, where someone would point at it and be like, "Oh, he's still just a puppy." But then I was looking at a Labrador Retriever that was almost eye level with me. It's like, this is not a puppy. Puppies fit in your lap. And but it's still extremely young because puppies grow fast. And birds, we have a bunch of birds in the wetlands that are baby birds, but they're the same size as the grown-ups.
No, birds are insane. Birds are the pinnacle of that. Birds grow ridiculously fast.
Which makes sense, since they are the descendants of the fast-growing dinosaurs.
Absolutely. They've perfected that. Well, I shouldn't say that, but they've, advanced that. They've taken that and run with it.
Perfected would be hatching from the egg at that size.
I'm ready. All right, let's go.
Like a kiwi, you lay an egg the size of you, and then just another one of you comes out.
And that's another actually thing to mention, is that dinosaurs did not give live birth.
Yeah.
No archosaur has ever, as far as we know, evolved live birth. All dinosaurs came from tiny eggs.
Which is cool.
So they all grew super fast. Another really interesting feature of dinosaur physiology is that there is a very good chance that all or most dinosaurs had bird-like respiration. We talked about how theropods and sauropods have air sacs, which are extensions of the lungs. Birds, and we talked about this at the end of an episode, thanks to a patron question, have a specialized breathing system where the air goes in a loop, so the old air and the new air don't mix.
Yeah.
Crocs have that.
Yeah.
It was recently discovered. So that's probably an ancestral archosaur trait. And we know that some dinosaurs also had air sacs. So dinosaurs probably had this very efficient bird-like respiration. Dinosaurs would also, for the same phylogenetic inference reason, almost certainly have had four-chambered hearts. Because crocs do, and birds do. And so they probably had very derived respirocirculatory systems to fuel their what were probably generally high metabolism bodies.
Yeah, high activity.
Yes.
It used to be thought that there were these slow lumbering animals, if only for the size, just that they were moving comparatively slowly, but it's very likely that these were very active creatures.
Yes. And then another one, possibly the catchiest evidence for warm bodies, are the fact that more and more dinosaurs are being discovered to have had feathers.
Be fuzzy.
Dinosaurs were fuzzy. There's a good chance that all dinosaurs, at least ancestrally, were fuzzy.
Mm-hmm.
Fuzz doesn't work. Like if we're inferring that these fuzz and feathers were at least partially, perhaps at first, for warmth, like fur is, birds use feathers for warmth today. That doesn't work unless your body's warm.
Yeah, you can't put a sweater on a lizard to keep it warm.
Yes, exactly. You have to radiate heat for the fuzz to trap the heat. So, and then of course there are all sorts of really awesome things that we can infer from colorful feather patterns in dinosaurs for social behavior and like the camouflage we were talking about before.
They could have had really crazy, and it's the fun thing with feathers is if anyone has ever watched videos of birds of paradise, you could get some weird things that are not like you can see a bird that looks normal and then it decides to fluff its feathers and looks completely different. So you get some really cool looking things going on.
Yeah. Feathers also, I was thinking about this the other day, feathers really mask body shape.
Yes, they do.
Like I was looking at my dog and looking at my cat, and my dog her skin is skin tight.
Yeah.
Like you can see every muscle and you can see her ribs. Like she's a very scrawny, like her fur is very short, her skin sticks close to her body. My cat is a fluff ball.
Yep.
And so you barely see the musculature under all that fuzz, you can barely see the body shape, and it makes me think of pigeons and owls, whose outer appearance doesn't look anything like what the musculature and skeletons are underneath. A lot of dinosaurs, especially small ones like Velociraptor and Microraptor, were probably a lot like that, probably fluffy animals.
Yeah, exactly. Like, when you look at an owl's face, it looks like it's flat, but their skull's shaped very much just like a hawk's.
Yeah.
It's not, they're still a bird of prey. They've just got flat feathers.
Yes.
Which is cool.
One more thing to mention real quick, because I don't think we can do a dinosaur episode without addressing the question of why dinosaurs were so big.
Yes.
Now, this is a conversation that I'd love to have in another episode, even a digression. Maybe we'll do a digression about this question, because I'd love to talk about it. Dinosaurs were huge. Kind of, right? I think that we tend to overstate this a little bit, because like I said before, for the most part, dinosaurs weren't ridiculous sizes.
Yeah.
They were on par with the largest terrestrial mammals. The largest dinosaurs were on par with them. What's interesting about dinosaurs, about their size, is partially that they consistently hit those sizes.
Yes.
Over and over and over again. Different groups, different lineages within different groups achieved elephant size.
Yeah.
Dinosaurs commonly hit horse size and bear size and cow size, which are not easy sizes to hit. Those are a bit uncommon. Sauropods are ridiculous. Just insane. And people love to ask this question, what allowed dinosaurs to get that big? And I think that the two quick answers, one is, we don't know.
Yeah.
We're studying it. We're trying to figure it out. We don't know. That's a hard question.
Mm-hmm.
I think a big part of the answer is going to end up being a lot of the stuff we've already talked about, right? High metabolism, super efficient breathing system, legs directly under the body, sturdy bones, right? Hollow bone structure is something that you see throughout theropods and sauropods, and that's something that they share with birds as well for strengthening the bones.
Yeah.
I think that a lot of people like to look towards the external environment to answer that question, right? Was there more oxygen? Was it because there were more plants? And that's those could have been factors, perhaps.
Absolutely.
But it really seems like these were animals that were built to be huge, or at the very least, their natural defining features were excellent for allowing them to reach huge sizes.
And the way to flip that question for anyone who has asked it themselves, or a way to think about it that might make it seem a little less bizarre, is another question you could ask is, why are aquatic mammals so big today? They're bigger than they've ever been.
That's true.
And it's the same sort. It's like, we're used to asking why are those so big, but we forget that, they're the biggest animal that's ever lived
Lives now.
lives now. So
Yeah.
it's not like things were big and now they're not.
Yeah.
So
The other
there's
way
lots
to
of
flip
factors.
The other way to flip that is to say why don't mammals get that big?
Mm-hmm. Yes.
Maybe dinosaurs aren't the weird ones.
Mm-hmm.
And I've heard it proposed that one of the big restrictions on mammals is that they have to devote so much energy to giving birth.
Yeah.
Like live birth, and then most of the time caring for your young really does take a ton of energy.
Yeah, if you
So if
scale
you-
it up from an
Yeah.
elephant to a sauropod, a baby sauropod's going to be almost the size of an elephant when it's born alive.
Absolutely. So if you're a sauropod and the only thing you have to worry about when you're having babies is plopping down a bunch of eggs and walking away, yeah, you got tons of, and that allows, and then of course the other thing is, whatever allowed sauropods to get big, right? Their bulk feeding, their special characteristics, their breathing system, their reproductive system. Once the herbivores are big,
Yeah.
then it's a natural progression to get giant carnivores.
Just like our island episode, the
Yeah.
size of one controls the size of the other.
So dinosaurs are a group of they are among the most well-studied groups of prehistoric organisms. They're actually among the most well-studied modern organisms as well.
Yep.
All sorts of questions, all sorts of groups. We have done a disservice to them by cramming them into a single episode,
Yes.
but there will be more.
Future episodes soon to come.
Yes, we have already gotten a handful of requests from people who want us to do specific dinosaur-related topics or specific groups of dinosaurs, so we have those on the list. If there is something that you'd like to hear more about, that we mentioned or that we didn't mention, literally every 5-minute chunk of this episode could be turned into another episode.
Absolutely.
Let us know. We would love to do it. We will talk about dinosaurs all the time.
They're pretty fun to talk about.
Indeed. But I think that that's it. I think that we have rambled about dinosaurs long enough.
Agreed.
I hope people have a little bit different perspective. The blog post for this episode, I'm thinking, is probably just going to be tons of pictures.
Oh, yeah.
Yeah, pictures, links, all sorts of the normal stuff on the blog post. Very visual. Big thanks, once again, to all of our patrons who support us on Ye Olde Patreon. Big thanks to all the people who have asked us to talk about dinosaurs. We will get to your requests in the future, we promise. Big thanks to all of our listeners, as usual.
Yeah.
Catch us on social media. Email us at commondescentpodcast@gmail.com. Follow us on Podbean or on iTunes. Leave us comments. Catch us on Patreon if you are so inclined. We release episodes every fortnight. So 2 weeks from now, keep an eye out for episode 22. I think that's it.
I can't think of anything else. We got to talk about dinosaurs for a long time.
We sure did. And I apologize to all the dinosaur fans out there for bringing up Jurassic Park 3.
It was painful but necessary.
Yeah, it was. Yeah, I apologize. I'm sorry, everybody. I won't do it again. I might do it again.
Yeah, who can know?
Join us next time on Common Descent.
We'll see you, everybody.
Thanks for listening to the Common Descent Podcast. For more from us, you can follow us on the Common Descent Podcast Twitter account, Facebook page, or on our WordPress blog where we post additional cool stuff for each episode. The song you're hearing is called On the Origin of Species by Protodome. You can find this and other video game remix music at ocremix.org. Thanks again for listening. We hope to see you next time.